You ever wonder how a self-driving car can instantly spot a pedestrian? Or how your phone's camera just knows where all the faces are in a group photo? Well, the tech behind it is called YOLO, and its main idea, it's way simpler and honestly a lot more chaotic than you'd probably guess. So let's just dive right in and demystify how computers use this wild method to see the world around them.
All right, here's how we're going to break it all down. First, we'll get into the core philosophy, this idea of the massive guess and refine. Then we'll see how the image gets set up with a grid. After that, we'll look at the two big, simple questions the computer asks itself. That leads us to, well, a mess of answers, and we'll figure out what to do with that. And finally, we'll wrap it all up with the core takeaway.
So let's kick things off with that central concept. It's a strategy that honestly feels a little bit like cheating, but man, is it effective. So think about this classic problem, right? You've got a super busy street photo, and you want a computer to find just one person in that whole crowd. How would you think it works? Does it scan left to right, top to bottom, carefully looking for clues?
Well, the wild answer is it doesn't really search, not in the way we think of searching. Instead, it just guesses. And not just one guess, we're talking thousands upon thousands of guesses, all happening at the exact same moment. It's this total brute force approach that sounds kind of crazy, but it's the secret sauce behind YOLO's incredible speed.
And this gets us to the official name for this idea, massive guess and refine. The best way to think about it is with an analogy. Imagine you hand a student a test. But this isn't just any test. It's like 100 pages long with 8,000 questions about a single picture. And here's the kicker, you tell them they have to answer every single question at the exact same time. That, in a nutshell, is the core of how YOLO works.
Okay, so if the computer is our student, before it can even start answering all those thousands of questions, we have to prepare the test paper, right? So let's look at how the image itself gets prepped for this massive guessing game.
It's basically a two-step process. First, the algorithm just throws a simple grid over the entire image. You can literally picture a giant tic-tac-toe board laid on top of the photo. Then, and this is the important part, at every single point on that grid, it places a bunch of predefined boxes. And these boxes have a special name. They're called anchors.
So what are these anchors? Well, they're nothing fancy. Seriously. Just think of them as a set of standard templates. At every one of those grid points, the computer plops down a few basic shapes. Maybe a small square, a wide rectangle for things like cars, and a tall, skinny rectangle for things like people. These are the starting points, the initial best guesses.
And here is where the scale just gets absolutely nuts. When you take those few anchor boxes and you copy-paste them at every single point on that grid, suddenly you've got thousands of potential boxes. We're talking over 8,000 of these best guess boxes, our test questions, all just sitting there on the image ready to go.
Okay, so we've got our test paper ready, covered in over 8,000 questions. But what are the questions? What is the computer actually asking? Well, it all boils down to two really simple questions for every single one of those boxes.
And these two questions are just beautifully simple. For every single one of those 8,000 plus boxes, the model asks, first up, is there an object inside this box at all? We can call that the objectness question. And then second, okay, if the answer is yes, how do I need to tweak this box? Stretch it, shrink it, move it around to fit that object perfectly. And that's the refinement question. That's it.
So you can probably see where this is going, right? When you ask over 8,000 questions all at once, and a whole bunch of them are pretty good guesses, you don't get one nice, clean answer. Nope, you get a total mess, a storm of correct answers, all at once.
And here's the key thing to understand. When the model finds that person in the crowd, it's not like just one box gets it right. Oh no, you'll have maybe 50 different anchor boxes, all in roughly the same spot, and every single one of them is screaming, I found the person, I found them.
And I know that sounds like a mistake, but it's not. It's actually the expected result of this whole massive guess strategy. You can think of it like a giant yes vote coming from all the boxes that are near the actual object. This big chorus of agreement is what makes the algorithm so confident, but it also creates this big visual mess of overlapping boxes. Which, of course, leads to the big question. So, how do you pick just one? If you've got dozens of boxes all claiming they're the right one, which one is the actual final answer? How do you clean up that mess? And that's where the final crucial step comes in. It's basically a cleanup process. Now, the technical term for it is non-maximum suppression, or NMS. But you can just think of it like a competition. Its job is to look at that whole messy cloud of correct boxes, find the single one that's the most confident,
and then tell all the other boxes that are overlapping with it to just go away. It picks the one champion and gets rid of all the noise.
All right, let's wrap this up and really lock in the main idea here. Why does this whole chaotic guessing game actually work so well, and why is it such a big deal in computer vision?
So let's do a super quick recap of the classic YOLO method. The core idea, massive guess and refine. The setup, a grid with thousands of those predefined anchor boxes. The logic, just two simple questions. Is something in here, and how do I fix the box? And the result, a messy but super effective cloud of detections that just needs a quick final cleanup to get that one perfect answer.
And what's so cool about this is that the core principle, this whole massive guess idea, is so powerful that it's still at the heart of even the most modern, cutting-edge models. You'll hear about newer anchor-free versions of YOLO, and while they might get rid of those predefined box shapes, they're still using some version of this exact same strategy, making a huge number of guesses all at once across the entire image.
So, what YOLO really proves is that sometimes the best solution isn't some careful, methodical search. Sometimes it's just a really, really smart, massive brute force guess. And it works incredibly well. Which kind of leaves us with one final thought to chew on. If this is what a brute force method looks like today, what do you think the next, even smarter evolution of computer vision is going to look like?